Hello, you guys. Let's start chapter 4 today with factors and prime factorization. Okay, so let's take a look at the vocabulary prime numbers. A prime number is any number that has exactly two factors. So it's always the number 1 and itself. For example, 13 has two factors, 13 and 1. And 41 has two factors, 1 times 41. Okay, a composite number is any number that has more than two factors. So, for example, 28 would be a composite number because 1 goes into it, 2 goes into it, the number 4 goes into it, 7 goes into it, so it has more than two factors. Now, prime factorization, when they ask you to do that, that means make a prime factor tree. So notice how I took the number 28 and I broke it apart. 4 times 7. 7's a prime, so I circled it. And then I broke apart 4 to be 2 times 2, and so I circled those. So the prime factorization of 28 would be 2 to the second power times 7. Okay, and then take a look here, monomial. That's an algebraic term, and that is just one term in algebra. It could be a constant, and remember, a constant is just a plain old number. It could be a variable, like x or y, or it could be the product of constants and variables. So here are some examples. 3x would be a monomial. W would be a monomial. 5x squared would be a monomial. Or 2xyz would be a monomial. Okay, let's take a look at example 1, writing factors. Let's say that we want to write all the factors of 18. Remember, when they say find all possible factors, I want you to use what we call a T-chart. Take a look down here. When it says find all factors, I want you to use a T-chart. Now, you did this a long time ago, but let's talk about how we do this in 7th grade. Put the number that you're asked to find all factors for. So put 18 up above, and then draw a big T. And then we always start with 1 because 1 is a factor of every number. So 1 times 18 would give us 18. And then go to the next number, 2. 2 times 9 gives us 18. And then go to your next number, 3. 3 times 6 gives us 18. And then you should try 4, but we know 4 won't go into 18, so we cross it out. The next number we would try is 5, and 5 won't go into 18 without remainders, so we cross it out. Since the next number we would write is 6, and we've already put it in our list, we know we're finished. And so all the factors of 18 in order would be 1, 2, 3, 6, 9, and 18. Okay, let's take a look at example 2, writing a prime factorization. So let's say they want us to prime factorize 420. This is kind of a cool chart because they show you that no matter how you start, you're still going to end up with the same answer. Let's take a look at this prime factor tree. Let's say that we want to break apart 420. See how it ends in a 0? That's how I know that 10 is a factor of it. So 10 times 42 would give me 420. And then I break apart the 10 to 5 times 2. And I would break apart 42 to 7 times 6. Now 5 is prime, so I circle it. 2 is prime, so I circle it. 7 is prime, so I circle it. But I'm not done with 6. I can break that apart into 2 times 3. And now they're prime, so I circle them. And then the next thing I do is just write this in order. But remember, put the bases in order from least to greatest. So see how 2 is the smallest prime number that we had in our tree? So I see I have 2 of them. So 2 to the second power, and then 3 would come next, times 3, and then 5 would come next, times 5, and then 7 is last, times 7. And so notice how I wrote it here with a multiplication symbol in between them, because if I multiplied all of these prime factors, I would end up with 420 again. Now, take a look down here. Let's say that we didn't start with 10. Let's say we started with 6 times 70, and then we went on. Well, again, we could break apart the 6 to be 2 times 3. We could break apart 70 to be 7 times 10. And then we can break apart the 10 to be 2 times 5. And so I'd circle all my primes, and then I would put them in order again. But I want you to notice something. No matter how we do our prime factor tree, we end up getting the same answer. And that's kind of cool. Okay, take a look at example 3 with me, factoring a monomial. Remember, monomial means we're going to see variables in this. So you can use factor trees to help you with monomials. Here's how I would do it. Notice how they gave us 24, x to the fourth power, y. So I wrote it here. Now when you break apart a monomial, you'll see on the two branches, I take the coefficient, the number in front of the variables, and put that on one branch, and then I put all the variables on the second branch. And now with the coefficient, with the number, it's just like before. Break apart 24 any way you want. I did 4 and 6, and then I broke apart the 4 to 2 times 2. I broke apart the 6 to 2 times 3. Now, what's new about this is the variables. So notice how I had x's and a y. So on my two branches, I'm going to put all the x's, x to the fourth, and then the y. Since there's only one y, I'm going to circle it because I can't break it apart anymore. But notice how it's x to the fourth power. Now my students started doing this a few years ago, and I guess it's fine. It's a faster way to do the tree. But since it's x to the fourth power, they would draw 4 branches, and then on the end of each branch they would put an x. And that makes sense, right? Because x to the fourth power is x times x times x times x. Okay, now when you write it out, here's the deal. I'll let you use powers on the coefficient. Okay, so notice how it's 2 times 2 times 2. So I wrote 2 to the third power, and then I put the 3 next. But you have to write the variables in expanded form. That means don't put it back to be x to the fourth y. Write x to the fourth out. X times x times x times x times y. Okay? So one more time, the numbers, you can use exponents to help you write it more quickly, but the variables you have to write out in expanded form. Okay, so take a look at the checkpoint here. Write all the factors. Remember, when it says all factors, use the T-chart. And so they want me to find all the factors of 28. So I wrote 28, and then I did a big giant T. Start with 1. 1 times 28 works. Then go to the next number, 2. 2 times 14 gives us 28. Then you should try 3. Remember, 3 won't work because when you add the digits, 2 plus 8 is 10, and 3 will not go into 10. So cross it out. Now try 4. Of course, 4 times 7 gives us 28. Now try 5, but 5 won't work because the number doesn't end with a 0 or a 5, so cross it out. 6, you should always try 6, but 6 won't work unless 2 and 3 work. Since 3 didn't work, 6 isn't going to work. And since the next number I would try is 7 and it's already in my chart, I'm done. So all the factors of 28 are listed right here. Take a look at 48. Okay, I would start off the same way. 1 times 48, and then I try 2. 2 times 24. Then I try 3. 3 times 16. Then I try 4. 4 times 12. Then I try 5, but it doesn't work, so I strike it out. Then I try 6. 6 times 8. And then I try 7. And of course that doesn't work, so I strike it out. Since the next number I would write is 8 and it's already in my chart, I'm good and I can stop. And so here are all the factors of 48 listed in order. Okay, take a look at the next checkpoint, number 3. It says, tell whether the number is prime or composite, and if it is composite, write its prime factorization. All right, so take a look at 97, and I know everybody wants to say, oh, 97, it's a prime, but before you say it's a prime, you better use the T-chart because your book is going to try to trick you, okay? So here's what I'm talking about. Put the 97 up above and do a T, and of course 1 times 97 works. 2 does not work because it is not an even number. 3 does not work because 9 plus 7 is 16, and 3 will not go into 16. 4 does not work. When you try it, it will not work. 5 does not work because the number doesn't end in 0 or 5. 6 doesn't work because 2 and 3 didn't work. 7 doesn't work, but you have to try 7, okay? If you put 7 into that, 7, it will not go into 97 without remainders. 8 doesn't work. And again, you have to try it. 9 doesn't work because of the digit sum. It adds a 16. And 10 doesn't work because it doesn't end in 0. Now, there's something cool about knowing why I stopped at 10 and I didn't try 11 and 12 and 13 and 14. You can always stop at the number because if I squared 10, so 10 squared is 10 times 10 is 100. And notice how 100 is bigger than 97. I don't have to try any more numbers. All you have to do is try up to the number's square root, and then you can stop. So that's how I knew I could stop at 10. And that's going to save you some time on your homework. Okay, but going back to their question, it's definitely prime, and so the only factors are 1 and 97. Take a look at 117. Again, you might think, that looks like it's prime. But if you try it, remember, add up the digits. 1 plus 1 plus 7, that would give me 9. So I know 9 goes into the number. So when I broke it apart, I used 9 and 13. Of course, 13 is prime, 9 is not. So I broke that apart, 3 times 3. So this is definitely a composite number because, and we did the prime factorization, it's 3 to the second power times 13. Okay, let's factor the monomial here. We're going to use trees. So I wrote 21n to the 5th power. Remember, use 2 branches. On the first branch, put the coefficient, the 21. On the second branch, put the variables, the n to the 5th power. Now break apart 21, of course, 3 times 7. And then since it's n to the 5th power, we drew 5 branches, and we put n's on all of them. So if I wrote this out, it would be 3 times 7 times n times n times n times n times n. Okay, take a look at number 6, 18, x to the second power, y to the third power. So when I use the 2 branches, remember I put the coefficient, the 18 on one branch, and I put all the variables on the other branch. So then I break apart 18, 2 times 9, circled the 2, broke apart the 9 to 3 times 3 and circled those 3's. And then look at what I did with the x squared y cubed. On the first branch, I put the x's, x to the second power. On the second branch, I put all the y's, y to the third power. Since it's x to the second power, I drew 2 branches and put x times x. Since it was y to the third power, I drew 3 branches, put y times y times y. And so when I wrote it out, remember, put the numbers in order from least to greatest. So 2 times 3 to the second power, because there were 2 of them. But then remember, we have to write the variable in expanded form. So x times y times y times y.